Let's take a look at drawing lines of best fit. So here we've got a scatter graph with a number of points plotted. Now to draw a line of best fit, all you're doing is drawing a straight line that cuts through the middle of as many of these dots as possible. So it's obviously a lot easier if you've got a ruler and a pencil, so I'm just going to have to freestyle it. So the line of best fit would look something like this. Again, my line's not perfectly straight. Now, I wouldn't stress too much about it. This isn't the only solution. If I ask 10 students to draw a line of best fit, they might all come up with 10 slightly different lines, and they might all be perfectly correct as well. So it's a trend line, a line that cuts through as many of the dots as possible. And I've programmed my computer to do this line of best fit properly, and it looks exactly like this. So it's cutting through as many of these dots as possible. Like I say, you don't need to overthink it, just something close to that will be perfect. So it's going through the middle of the dots, and as you can see, this line is going up, so there is a positive correlation here. We know there's correlation because all of the dots are pretty close to that line. Again, drawing a line of best fit here, we've got negative correlation because as we are increasing on the x-axis, we are decreasing on the y-axis. But my line of best fit is going to cut through as many of these as possible. So it's going to be something along the lines of that. Again, that's a very wiggly line. When you do it, definitely use a ruler. I'm just freestyling this on my graphics tablet, which isn't ideal. But if you do it properly, it would look something like this. Again, we can see that most of the dots are all of the dots are close to that line, some closer than others. But again, I could ask 10 students to draw this line and they would all draw it differently. And it doesn't mean that 9 of them are wrong and 1's right. They might all be right. So as long as the line is generally cutting through the center, this is the trend line. So we can clearly see that it's going down, therefore negative correlation. Now we can use a line of best fit to predict other values. So this graph shows how long it takes a group of children to complete a puzzle. It's not a great graph really because we don't have very many points on it. So first of all, I'm going to draw in a line of best fit. So something like that will do. It's not excellent, but we can see there's negative correlation. Most of the dots are pretty close to the line. That's good enough. Again, yours could differ, but doesn't mean yours is wrong and mine's right. They might both be fine. So we're going to use this line of best fit to make a prediction for how long it takes a 9-year-old child to complete the puzzle. So I'm assuming that across the bottom it's not been labelled, but this is our age. So all we're going to do is we are going to go and find 9 years, which is halfway between 8 and 10. And we are just going to go up to the line here and take a reading over to the left. Now, since there are many ways you could do the line of best fit, I mean, your line of best fit will look very similar to this, but your reading for 9 might not correspond exactly to mine. So there's not going to be one perfect answer here. If this was a question in exam, the exam board would accept a range of answers for sure. So since 9 corresponds to this mark here, I could argue that that corresponds to a time of 50 seconds. Although it does look like it's slightly above, so 51. Probably they would accept anything between 45 and 55 for a question like this perhaps. So all you need to do, draw in a line of best fit and then use it to take a reading for some other point.